Hello, trigonometry. Hope you guys are doing all right. And this will be the lesson on 8.6, the dot product and its uses. This is actually going to be a two-part video. I'm going to split it into two videos. I'm going to focus specifically on the dot product for today, and then part two, we'll talk about its uses. So, before we talk about the dot product, I just want to give you a quick bell ringer of what you learned last week in 8.5. So given the following vectors, vector u and vector v, both in their component forms, we're going to calculate negative 3u plus 8v. All right? So negative 3u plus 8v. So in other words, we're going to be doing negative 3 times vector u, where vector u is negative 8 comma 3. Then we're going to add that to 8 times vector v, where vector 3 is negative 6, 0. If you guys remember from last week's video that to multiply these, it's basically the same as distribution. So you can distribute the negative 3 to vector u, and that is going to give you 30 comma negative 9. Then do the same thing with the 8. Distribute that to vector v, and that'll give you negative 48 comma 8 times 0 being 0. And then once you've done all that, now you can just add the two vectors together. And the way you add them is you'll add the first numbers together to get negative 18, and then you'll add the second numbers together to get negative 9. And that is how you take care of that. But now, what if specifically I didn't want you to multiply numbers, but what if specifically I wanted you to multiply vectors? Like if I had 1, 2, 3, 4, what if I asked you specifically to multiply the vectors? Some of you may be thinking, oh, what if I just multiply the first numbers to get 3 and then multiply the second numbers to get 8? It should be easy just like that, Ms. Shulin, right? 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 Fortunately, it's there's a bit more to it. It's not complicated, but there is a bit more to it. So sadly, that is not how you multiply vectors together. And I will show you how to multiply vectors in the next video. Or in other words, I'm going to show you how we do the dot product. Oops, wrong thing. Here we go. Before we begin, if you need a calculator, you can go ahead and use this one. Go to eeweb.com/tools/calculator. It's pretty useful if you ever need to use it. Today, we're just going to be basically computing simple calculations. We won't be using sine or cosine today, or tangent. So just want to let you know, this should be easy computations today. All right, so back to the main slide. So now, here is the formal definition of a dot product. When we do the dot product, it's basically taking two vectors and you're finding the product of them. And usually since the product is signified by a dot, that's why they call it the dot product. And the way that it works is that our final result won't actually be a vector. It's actually just going to be a regular number. And this is how it works. You first take the first results of each of the vectors, like u1 and v1, and you multiply them together. Then you'll take the two results of the second numbers, so u2, v2, of those two vectors, and you'll take those and then you'll multiply them together. So in other words, you'll end up with two numbers. You multiply the first numbers together and then you multiply the second numbers together. And once you have those two numbers, you just have to add them together, and that will give you the official dot product answer. So that's it. You multiply the first numbers, then you multiply the second numbers, and then you add them together. And that's the dot product. So let's try an example. So let's say we have these two vectors, and we need to find the dot product between them. So u dot v. So first thing we're going to do is, as I told you before, multiply the first numbers together, negative 3 and 5, and that'll give you negative 15. Then multiply the second numbers together, the 3 and the negative 16, to get negative 18. So those are your two numbers, and once you have those two results, you just have to add them. So negative 15 plus negative 8 gives you negative 33. So the dot product of u times v will give you negative 33. Again, notice how when you multiplied a vector with a vector, you did not get a third vector as your final answer. That's only when you add or subtract. Here, we're multiplying, and multiplication will just give you a regular number. No vector, no v component form stuff, just a regular number. And that's the dot product in a nutshell. We'll do a couple more examples just so you can get familiar with it. So this time we do have a product of u times v, or u dot v, but now we also have a scalar. So in other words, once we find the dot product, we'll need to multiply by negative 4. So let's go ahead and do that. Let's do the dot product of u times v. We'll do that first. So u dot v. So first, you'll multiply the first numbers to get negative 15. Multiply the second numbers to get negative 18. Add the two results together, and that will give you, as before, negative 33. But we're not done here, because once we found the dot product, we were then supposed to multiply it by 4. So there you go, negative 15 plus negative 18 gives you negative 33. Now you got to multiply by 4, and that will give us the answer, 4 times negative 33. 4 times, hold up, 4 times negative 33, enter, negative 132. So when you do 4 times the dot product of uv, your answer should be negative 132. And there you go. Now some of you may be wondering, whoops, Ms. Shulin, did I have to do the dot product first? Couldn't I say, for example, I'm just going to clear the work. What if, Ms. Shulin, what if I multiplied the 4 and the u together and then do the dot product? Could I do that? Well, let's see if we get the same answer. Let's find out. So yeah, let's try that. Let's try doing 4 times the vector u first and then do the dot product. So 4 times vector u, where vector u is this. So 4 times negative 3, 3. We distribute that. That's going to give us negative 12, 12. Okay, so now that we've done that, now let's take that and do the dot product with vector v, where vector v is right here. So 5, negative 6. Let's try it. So now that we got to do the dot product, multiply the first parts, negative 12 and 5, and that should get you negative 60. And then you got to do 12 times negative 6, and that should get you negative 72. Once you have those two results, add them together, and that should give us our answer. And let's do that. Negative 70 plus negative 72. Or negative 60, sorry. Negative 60 plus negative 72. Enter. Which, well, look at that. That gives us the same answer as before. Negative 132. So, we have just proven it doesn't matter what you do first. You can do the dot product first, or you could do 4u first. Either way, you should get the same answer of negative 132. Now you know. So, whichever way you like better, do it. Okay, let's do one more example. Okay, so this time we have the same two vectors, u and v, but now we got to do the dot product of u times the dot product of uv, and then multiply that by 4u. So I'm just going to write that out. U dot v is in parentheses, And then it looks like we're going to have to multiply that by 4u. Okay, let's go ahead and do that. First, if I do the dot product of uv, multiply the first parts to get negative 15, multiply the second parts to get negative 18, and then just add those two parts together. Then we're going to have to times that number by 4 times the vector u, where the vector u is right here. So 4 times vector u, which is negative 3, comma 3. All right, let's do it. Continuing from there, negative 15 plus negative 18, you guys already know, that's going to be negative 33. Then we had to multiply that by 4 times negative 3, comma 3. Now this time it's not a vector times a vector, it's just a vector times a scalar number. So this time you just have to distribute and your answer will just be a vector. So 4 times negative 3 will be negative 12, and then 4 times 3 will give you positive 12. Okay, so that leaves us with negative 33 times negative 12, comma 12. I wish I would turn those off. I mean, kids aren't here. Once the kids are here, then you can turn those back on. Anyway, I do miss you guys a lot. But back to what I was saying, we got negative 33 from the dot product, and we just did 4 times the vector negative 3, 3 to get negative 12, 12. So now we just have negative 33 times the vector negative 12, 12. And again, it's just this time it's just a scalar number times the vector, which means you just have to distribute. So this is one of those cases where it ended up our answer actually turned out to be a vector this time. So negative 33 times negative 12. Let's see what that's going to be in the calculator. Clear. Negative 33 times negative 12 gives you 396. So the first one will get 396. And then this one, when you multiply negative 33 times 12, you should get the same number, but just negative. So you're just going to have to be careful how you're going to take care of these. Depending on what your final answer is going to be, you might just get a regular number, or you might get a vector, depending on where your dot product is in the problem. So now you've had examples with those. I got one more example, then we'll be done for the day. Now this one says find the dot product of these equations. Or in other words, we're still doing the dot product of u and v, but they're not in their component form anymore. They're in their ij form. Ooh, now, I want to see how many of you remember from the last video from last week that I is the unit vector 1, 0, basically saying 1 unit to the right, but multiplying that by negative 9 means that you're actually going to move 9 units to the left, which means you would have negative 9 in the first spot. The j is the same thing as the unit vector 0, 1, which is 1 unit up. But multiplying that by negative 5 makes it go 5 units down. So in other words, the negative 9 and the negative 5 from this is literally the same thing as the component form negative 9, negative 5. So in other words, this is the same thing as vector u. And for v, it's the same thing. Multiplying the 4 and the 5 by I and j is just a component form 4, 5. So you could use 4, 5, and it would be considered the same thing as vector v. And now all you gotta do is just find the dot product of those two component forms, and you're good to go. So let's go ahead and do that. So we got to do the first numbers, multiply those first, so negative 9 times 4, which will give you negative 36. Then multiply the second numbers, negative 5 times 5, which will be negative 25. And once you have those two results, add them together. And you will have your dot product for UV. Let's double check that in the calculator. Clear, negative 36 plus negative 25. And you get negative 61 is your dot product. Okay. So this was just an introduction to the dot product, and that's the end of the part 1 video. The part 2 video will talk about how we use the dot product in useful situations with finding angles and dealing with sine/cosine. So with that said, go ahead and watch the second part video, and if you have any questions, you know how to get a hold of me.